Thanks a lot for coming here. In long-lived software systems, most of the defects in production occur in those areas that changed since the last release. There's a whole body of research that tries to find out which areas are most bug-prone, and one of their key results is that most of the bugs are in those areas that changed since the last release. As testers, this probably won't come as a surprise for you. What was really surprising for us, however, is how much code goes through testing entirely unexecuted. So how much code and how much change code gets shipped entirely untested. And in this presentation, I want to outline test gap analysis as a tool that allows you to find untested changes before you ship them into production. But before I start, if you have questions, please interrupt me immediately. And it need not be well-articulated questions. It's fine if it's just opinions or doubt. I think it makes it more interactive and you can take more out of the presentation. And since I want to present our experiences with test gap analysis, just a short background on me, on where those experiences come from. I have two professional roles. On the one hand, I work as a postdoc researcher in the research group at the Technical University of Munich. And in that role, I'm most interested in what is relevant to measure. Because one of the key fallacies in research and software quality is that we measure a lot of things that are easy to measure, but not relevant to know. And in the researcher role, I'm interested in what is really relevant to know. And in the founder role of CQSE, I'm interested in how to have an impact. Because just installing a tool and running it as an analysis doesn't help anything. And here I'm interested in how can we build analyses that really have a positive impact on how we build and deliver software. And my third role is I'm a junior fellow of the Gesellschaft für Informatik, the German computer scientists foundation, and I'm trying to have more exchange between research and practice. I'm especially happy to be here today. This is a couple of the companies we work with. This is not meant as an advert. The main message I want to send here is test gap analysis and our experiences with it are not limited to one programming language or one organization type or one type of software. You see a couple of business information systems, you see a couple of embedded software producers, and we have some teams that are very agile, like the LV1871 here. They had Ken Beck himself in-house, and we work for some government agencies, like the Bavarian police, where maybe the first thought when you think about how they may develop software is not agile. So my main message here is that what those companies have in common is that software is critical for them, and that they have long-lived software systems that they need to test, and they can't always test everything. So they need to make conscious effort allocation decisions, and test gap analysis helps them to focus a significant part of the tests on those areas that changed. Why do we think it's important? We made a research study with Munich Re. There's still 2 seats free here in the first row for those that stand there in the back. We made a study with Munich Re, which I can disclose since we published it at the scientific conference. And the very simple illustration means this is the entire system, and this is the part that changed since the last release. This is what they covered in their tests, and now we have tested changes and we have untested changes. And in the study, we quantified these. And we analyzed 2 entire releases, and in the first release, 15% of the code that existed was modified since the last release, and half of those 15% went through testing unexecuted. In the second release, it was even worse, 60% went through. And then what we did was we monitored the system for a long time. Every single bug that was reported by the users was traced back to the source code, and we analyzed was that source code that changed or not, and was it tested or not. And not surprisingly, field fault probability was 5 times higher for untested changes. This is not the interesting part of the study, I think. I think the interesting part is how much code slipped through, because Munich Re has a very structured testing process. And this was a study we did in retrospect, which is interesting from a scientific perspective, but not so interesting for the people involved, because they say that it's not useful to know that in hindsight. So what we built is test gap analysis, and it's a hybrid analysis in the sense that we use a static analysis to determine what changed. For that, we connect directly to the version control system to recognize every single change a developer makes to any branch of the software. And we have a second part, which is a dynamic analysis, which traces test execution testing activities that take place, meaning manual tests and automated tests, Tosca tests and unit tests and so on. And then we throw that information together to see where are untested changes. To be better able to show examples from practice, I want to use a tree map, which Wolfgang also mentioned in the keynote today. And the basic idea of a tree map is that we use boxes to depict components of a system. In that case, it's a business information system. And every box here represents a business component or a technical component, UI base classes, dialogues, and so on. And now I go in deeper. Now, every small box represents a class, and the surface area of the class corresponds, the surface area of the rectangle corresponds to the size of the corresponding class in lines of code. And now I go in one level further. Now the small boxes are methods, the executable parts of a system. And it still holds the bigger the surface area, the bigger the corresponding methods in lines of code. Layout is performed by an algorithm according to package structure. Now, I use these tree maps to show changes, execution, and test gaps. In this system, developers worked for half a year. This was pre-agile transition in that organization. So 20 developers worked on roughly 2 million lines of code for half a year. And gray means the code that did not change. Red means new code, orange means code that was there before but changed. So we see there was not a lot that did take place here, and a lot of changed code appeared here. I used the same visualization for execution. Now, everything that's gray means it was not executed during test. Green means executed during test. And in this visualization, I have both manual and automated tests, and not only from a single version, but what we often see is so-called cumulative testing. Maybe you have a 2-week test period, and the first 3 days you execute tests on one version, then you get a new patch, and you continue testing, but you don't repeat all the tests. So we aggregate the data together in a way that it's only green here if it did not change after the test. And I think the interesting view now is the test gaps. I used the same tree map, and the colors now mean the following. Gray means unchanged. So this is the code that did not change since the last release. The colored stuff is the new code, or the changed code, and only if it's green was it executed during testing, either in a manual test or in an automated test. And what we're interested in is seeing if there's big red chunks. And here we see in this system, in this test phase, there were entire components which were not at all or almost not at all tested. And we use test gap analysis in a way that it's fully automatically computed, and so that as testers, test manager, developer, and so on, every single day you get fresh test gap tree maps to be able to make a conscious decision on whether you want to let code slip through untested or whether you want to still do some tests. And in this system, what happened here is we spoke with the developers and the testers. This system had one contractor doing the development work and another contractor doing the testing. And the test contractor had a test factory in India, which did exactly those tests they were supposed and told to do. And the program management bug was that the test factory was only transmitted regression tests. They didn't get any tests for the new code, which is a project management error, not a fault of the test factory. And in this case, it was critical, and they decided not to release it like this. Instead, they did an exploratory test, or in German, Trampeltest, where they took requirements engineers and end users, and they let them use the system without structured test cases, relying on their knowledge of the domain, and that they would report bugs if the system behaved differently than expected. And there, after 3 weeks of testing with 23 explorative testers, we got this map. At least we didn't have the big red chunks, but we still had some areas which were untested and were then inspected and where further testing took place. Now, I said I'm a researcher, and I also want to outline the limitations of such approaches. And our goal is not to have 100% change coverage per se, because there might be areas where it's not problematic if we don't test them. For example, in this system, there was a lot of new code here, which we inspected with the developers. It was not tested, but it was not a problem because it was not yet reachable. Remember, they had 6-month release cycles, and some of the developers prepared code for the next release, which was not yet reachable. It's questionable if it's a good development method idea, but from a testing point of view, that's not problematic. Same here. Here was code that was not reachable anymore. From a development point of view, that should be deleted, but from a testing point of view, it's not problematic if it doesn't work because it can't be executed. 1 second. The code here, however, was critical. It was not used by anyone because it was hidden in the UI, and they retested that. There's a question?
The code you mentioned that was not used in this release, stay as a new code for the next release?
Yes.
Otherwise, you don't have this match that it's new and untested. It would be not new and untested.
Correct. Correct. Then you have to remember that in the next release, very good thought, that in the next release it wouldn't show up as orange anymore and you would still have to test it. That's correct. Another question?
How are you able to connect the manual test case to a certain network of?
Very good question. I have a slide on that, 2 slides further, so let me postpone that question. But further questions at this point to test case? Yeah? How do we manage obsolete code? Do you mean how we detect it? In that case, like from the test gap analysis point of view, we don't really care how you manage obsolete code. But as a developer, we also work a lot with the developers. We suggest that they delete the code that they don't need anymore, or at least mark it as obsolete so that it can be deleted half a year later when it really didn't change and wasn't used anymore. For example, yes, or by moving it into a different package which has the name obsolete in it so that everybody knows it is it when he wants to work with that. And the second limitation I want to stress is that even if we had 100% change coverage, this would not mean that we had no bugs. As always, testing can only show the presence of bugs. We can never prove its absence. And I always try to say execute during test for the green areas not tested, because test coverage as an instrument is a bit coarse. We know that it was executed during test. We don't know how thoroughly it was really tested. So for all the green areas, there can still be bugs inside we haven't found. But for all the orange and red areas, we know that every single bug in there cannot have been found because it was never executed.
So on the load level, it's only on function level and not on statement. So if there's if statement in a certain function, do this or do that.
Yes.
Then if only one branch is covered, then the other is not, and then it's still green.
Also a very good question on which level of granularity do we do this profiling. This depends a bit on the technology. We can do it on a statement level, but again, for all the red ones, since the entire method was never called, we know that every single statement and every single branch and every single path has not been executed. For the green ones, especially for the big ones, we don't know how thoroughly. We can use profilers that do a statement or branch level analysis, but they often have a higher performance impact. So it's a bit of a trade-off decision between low performance impact for more coarse-grained analysis and more depth of information. The funny point is, I always only get this question in such a presentation. When a company uses that on their own system, they typically have enough of those big gaps that they don't want to know about smaller gaps, which would increase the number only. But we have that on the roadmap, and it's a valid question. Now let me just go through the next slides before I go to that question. I want to cover some rough use cases because there's different ways of using test gap analysis in practice. One is a hotfix test. This is an example from an SAP system. A patch was deployed, and now you want to make sure that the patch doesn't introduce a new bug because the customer is already a little itchy. And the first thing you usually do is make sure that the bug is really fixed. And with test gap analysis, we can see in this case from the 8 methods that the patch affected only three were covered. And now we put a tester and a developer together, make them inspect the further changes, and determine what further tests should we do to make sure that we didn't break anything on top of that, until we reach a completely green state. I want to come back to the question you asked before. If we know those test gaps, what can we do to determine which test cases would we need to run to execute those test gaps, or how critical are they? And there's 2 different answers to that. The first one is the one which requires less technology, which is we simply put a tester and a developer together in one room, using the tool and just looking at the code. If you click in the tool at the tree map, you directly jump to the code, have the version history information, the ticket information, in which context a change was made. And this from our experience, works pretty well. The second solution is to throw more technology at the problem. And our tool team scale is integrated with the version control system to know all the changes, is integrated with the ticket system to know in which context the change was made. And many developers specify the ticket for every commit they do. For example, this is a log from our own system, and the ticket 9838 was touched in all those blue lines. And what we can do is analyze the log to find out all the methods that were changed in the context of a ticket. And then we can throw the test coverage information against that. And then we can compute ticket coverage. By that I mean, for every single ticket in our system, be that a bug, a change request, a user story, an epic, whatever that's called, as long as it's managed in a ticket system, we can compute the ticket coverage. How many % of the code implemented for the ticket was executed during testing. And this is not yet the test case you would need to run, but it's at least closer to the functionality and easier to do a priority decision. Because maybe you have more test gaps than you can cover in your test phase, and then maybe you want to prioritize them according to risk, and having the ticket it belongs to is a significant step towards getting closer to risk. Yes, sure.
Could you go back to your this one? So that means you rely here in this case on the comment written by the developer to explain. So if someone is doing shit
Yeah.
comment, you rely on the shit written by the developer. It's not based on the technical object changed by the developer. In this case, it's on the comment based written by the
Very good question. What happens if a developer does not specify which ticket something was for? Then we still find it as an untested change. We just don't know which ticket it belongs to.
Okay, it's to link to the ticket.
Yes.
So in some cases, you could have a wrong ticket or...
Yes. We could have a wrong ticket.
But you still analyze technical object change.
Yes, we still analyze every single change to the source code, independent of how it was made to the system.
Okay, not necessarily the right ticket assigned to the change.
Yes.
But at least the impact analysis or the test analysis system based on the technical.
Yes. That's a valid point, because our experience is if there's only a guideline telling developers to map to tickets, then often they don't, because they don't see the point. But if there's an analysis that produces useful information, we see that they often consistently map tickets. But even if they don't, we can still find the untested changes. Further questions on test gap analysis at this point? How much time do we have left? Okay.
So just to clarify, this will focus on functional testing, right? Not like security testing, for example. It can, the test gap analysis won't add value to insecure code.
Good question. Does the test gap analysis contribute to security? No, not at all. We do have incremental security analyses in our tool that discover SQL injection attacks, for example, by doing incremental string taint analysis. And I'm happy to answer questions on that, but that's beyond of the scope of this talk. There's a static analysis we do, and we have one PhD who is working exclusively on that, but this is apart from test gap analysis. I want to give a short sneak preview beyond test gap analysis. Because one problem we often see with companies that are successful with the automated tests is that their test suite size grows, and executing all tests takes longer and longer. And this increases the time between introducing a bug and having a failing test case, and this lowers the value of the test suite. And we are in a good position to fix that because we know which code changed, and we know which tests cover which code, and we can, for some languages and working on a Tosca integration, capture the test coverage per test case. And then we can decide if you run, for example, your tests on a daily or hourly basis, we don't need to always execute all tests, but we can decide which tests will most quickly find bugs introduced by the changes since the last test run. And we do it in 2 steps. The first one is to select. Imagine every single dot is a test case. And we can remove all the non-impacted tests, meaning those tests that don't execute any of the changes made since the last run, because we know they can't find a bug. This cuts down the number. And the second step is to prioritize the sequence of the remaining ones to find a new bug as early as possible. How does that look? If we would run them all, we would know which ones pass and the red ones which fail. So the ideal sequence would be to running the failing ones first. We don't know that, but we can approximate it to have the failing ones run early at least. So cutting down the entire suite to a much smaller chunk. And if you want to break the build on the first failure, this significantly cuts down the execution time. We've run an empirical study on this on a couple of open source systems and on our own system team scale. And in those studies, we found that we find 90% of the bugs in 5% of the time. So you find a lot already during continuous testing. You still have to do the big run every week or month to have an accurate mapping and to find the 10% bugs that slip through. But you find a substantial amount in a very short time. And this is where we integrate, where we plan a tighter integration with Tosca to automate that for tests. I'm running out of time. Let me just wrap up so that we have time for one or two more questions. We know from research that code changes are a good fault predictor. And test gap analysis makes changes in test activities transparent, so that you can make a conscious choice on whether to do further testing or ship as it is into production. And we're happy to support an evaluation. And as Mike said, we have a booth in the conference area.